Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
So, during what we have been talking about during this topic, so in this topic we have been talking about applications, we have been talking about conductivity, and we are going to look at the reasons why we have been talking about conductivity. So we have been discussing about very many things, so we can talk about the applications of conductivity measurements, So some of these applications we have seen determination of molarity, which we have been calling solubility. Like for example here, we can use conductivity titration to determine molarity of solutions. We can use them to determine conductivity at infinite dilution of weak electrolytes, which will help us to determine the degree of ionization of weak electrolytes. If you remember very well, we had something like this. As we summarize our topic, we said that molar conductivity is equal to K over C, and we also say this C is our concentration, which can also mean molarity, which we refer to as solubility. So we can use conductivity measurements to get molar conductivity at infinite dilution, which will help us to get the degree of ionization. So this degree of ionization, as we discussed, can help us to degree of ionization. It can help us to determine the pH of solution by first getting the ionization constant, that is for acids, times C, and then after getting pH for weak electrolytes, which is negative a half log CK A. So this is a summary of what we have been discussing about. Then again, as we have talked about today, it can also help us to get the KSP values. As long as you have the molarity, you can get the KSP values. So before we get the KSP values, we are supposed to get what we call solubility in moles per liter, per liter. Then after, we get solubility in grams per decimeter. All these are important, which are different concentrations. So from here, you can get the KSP, and which is actually the solubility product. Then finally, today, we have been discussing about these conductivity titrations. So conductivity titration, you remember when you're talking about mole concept, in senior 3, we are trying to talk about the different types of titration. So we can also have other types of titration where we use conductivity measurements. So finally today, I'm going to leave you with a question, a small exercise which says, sketch the graph to show the variation of molar conductivity of the following conductimetric titrations, and explain the shape of each graph of the following what? Reactions. The following what? Reactions. So we have titration, some graphs like titration of a solution of HCl against sodium hydroxide. Like, so you need to sketch it like we have done here. That is HCl and sodium hydroxide, then you explain. So this is a sketch and this is the explanation. Then we can also have titration of sodium hydroxide against ethanoic acid. This is the strong base, weak acid. Yeah, this one. You sketch. So this is a sketch, and then this is our explanation. Then again, you also have ammonia against HCl. That is weak acid, weak base. So you can sketch. This is our sketch, and then after you explain. After you what? You explain. So then silver nitrate against sodium chloride. This one we have not done it, but we can also try to sketch. Like for example, we can try to sketch. Like for example, we have a reaction between silver nitrate, nitrate and the sodium what? Chloride. So this one will give silver chloride and the sodium what? Nitrate. You see, it's a precipitation reaction which will form a precipitate here. What? Precipitate. So normally, when this reaction is taking place, our titration curve will be like this. So when it is taking place, it means when the silver nitrate or the silver ions are replacing the chloride ions, when they are replacing the chloride what? Ions, we have a straight line. Why? Because normally the ions are replaced themselves. They replace what? Themselves equally. Then when you reach end point, we shall have a sharp what? Increase. So we have here, we can say A. Can you say AB? A, B, and what? C. Then here we shall have a sharp increase. Why? Because of excess silver nitrate, which is added. Excess silver nitrate, which is what? Added. So here we shall have our end point. End point. Hope you've got the explanation. So you try also to sketch and make some what? Research. Make some what? Research. So thank you very much for following me in this topic. Hope you've got something, especially our applications of conductivity. So they can be applied. They can be what? Applied. So make discussed, even the trial questions. If you've not tried some of them, you can look for more work and you can make more research. So we shall meet next time. God bless you very much.